Hello.
Hello,
Hey, Steve.
how are you doing?
Yeah, I'm good. It's start of the school year, so kids are settling in.
Nice.
Uh,
Uh,
yeah, the days are getting shorter. I'm not a huge fan of that.
yeah, I was gonna ask, how's the weather? Is it getting any better there?
So allegedly we're gonna have a nice weekend.
Nice.
So let's hope that that stays that way. Hello.
Hello. Dear. Welcome back,
Hello.
Sam.
Hello. Welcome back.
I put two items in the agenda because there was nothing, but it seems like people are filling things in. So, which one do you folks want me to demo, slash drop, or do you want me to demo both? I don't want to hog it to 30 minutes. That's my stuff.
Go for it. I don't think you need to apologize for filling the agenda.
Cool. Okay, then let's get started. Onto the demo, something not actually a demo, but like more of a walkthrough because we're still building this at the moment. And it is what we've been calling the topology service transactional behavior. And for people who are not aware, topology service is one of the cluster-wide services that we're deploying for cells. So it sits on top of all cells, and it's gonna be holding some tin metadata to route logic, meaning, for example, it will know where GitLab or GitLab on which cell it lives, or like where that user lives or where that organization lives. So our HTTP parameter can route it to the correct cell. And the way this works is it needs to Rails. So every time you update GitLab project path or create a new project or whatever, um, we need to sync that information to topology service, right? Just so we know, hey, the path for GitLab or GitLab got updated, so we need to start routing a different path or whatnot, right? Or a new project got created and we need to start routing to that new project. Um, so uh, we've been building this transaction syncing logic here, and this is the happy path. Like there's a lot, like in every piece of the flow here, everything can go wrong, like Rails application crashes or and things like that. So um, I wanted to walk through a little bit about around this to see what in general what people think and what not. So um, it all starts with, for example, here it's going through a user creation, right? So we begin a database transaction. We'll validate all the models like normal, collect all the models, and then send the request to topology service. And this is the first red herring, which is we're sending a web request within a database transaction. Um, and this is for a few reasons. We've tried really hard not to, but unfortunately, we have to. One, because we need the IDs on the database. Um, so, for example, when you create a project, we need the project ID, so we send it to topology service. To developer ergonomics, we could create like a service class where you first create topology service and then do the user.save. But that would have resulted us into going into all the code, looking at all the save methods for user.save or any other model that we need to claim. So that would have been a never-ending task going through the save. Also, Rails console access would not go through that. So, for example, an SRE would put on his cowboy hat and update the username through the Rails console and not trigger the claims. We do have reconciliation loops behind the scenes, but again, that will be eventually consistent. So we also explored the idea of overloading the save and update method in active record for certain methods, but that didn't work out pretty well. So with the database team, we set some constraints for us. So hard time limits, and circuit breakers and things like that on the Rails application, so we don't slow the transactions too much. And something I learned when we were exploring this is we do this for Gitly as well. So we send Gitly RPCs within database transactions as well. So it's not something like it's hard, it's bad, but at least it's not a new bad that we're introducing. So, anyways, we send the request to topology service, store it in Spanner, which is the storage we're using for topology service. And after topology service gives us a response, we actually save the changes inside of the Rails database. And the important part is the lease outstanding, which is in the begin update RPC, we're just saying that we want to claim these. So this is just checking, hey, does username Steve exist or not, and baiting early. And when we're saying this, we're not committing it. We're just saying we're leasing it, saying, hey, we want to use this username, for example, right? So lease outstanding here is inserted locally in the Rails DB. And this is purely just in case the application crashes between here and here, right? So we can recover from that. And then lease commitment, after we commit the transaction, we say, okay, everything works, the database and the Rails is committed. So let's commit it in topology service, and then will respond to the user. And then here we have, let's see,
Hold on,
try and find it.
I have a
Go
question.
ahead. Go ahead.
Why do we need to respond to the user after we've committed the lease?
Because we can't tell them that their user exists or their user creation was successful unless we get consensus between topology service and Rails that, hey, Bob is actually yours now. Because this one is just leasing it, this one is committing the lease.
Yeah, okay. And if the committing, what happens when committing the lease fails?
Then we return that the user was
and we
not
need
created.
to roll back the database changes in the Rails app as well.
Yes, yeah, and that's where the background reconciliation happens.
Got it.
Where we'll do. You see here, for example, we have up destroy or up create. So topology service only creates or destroys, it never updates records. So even if, for example, you change Bob to Bob2, you'll end up holding two resources, right? You create a destroy lease on Bob and the create lease on Bob2. So we don't even update any record. So we keep the API fairly simple. And then we have a reconciliation loop in the background, checking for outstanding leases and things like that. And we also have, I won't go into these too much, but verification service where it will walk through all the, for example, user table and verify, hey, are these all claimed in topology service, just in case, again, someone does an insert query on the user model on the user table without looking at topology service, this catches it, hopefully. And I wanted to walk through a little bit quickly through an example of how everything is working, not like how the data model looks like. So For example, this is the routes table. If people are not familiar, the routes table in Rails is like a 75 million record table holding all the routes for GitLab. So GitLab board, GitLab is in here. It has all this information. We transform it into this gRPC request for topology service, holding, for example, the owner, meaning if it's a group, if the group owns it or whatnot, the source, meaning the actual information in the routes table. So I'll walk through an example, and then we'll store this inside of the claims table in topology service. And walking through an example here, for example, we have a route record for GitLab or GitLab, and we're transforming into a bucket. We're storing it in the routes bucket for GitLab, and the value and the owner of this project and the source. So like this, then we can use all this information to classify by ID, for example, classify by path, because for example, in the API, we allow encoded paths to be passed in rather than IDs. So we need to classify by path as well within the API, for example, and we'll have all that information here. So yeah, that's mostly the transactions and stuff that it's still work in progress. I'm not just going to say it's done, but yeah, this has been taking up most of our time. Any questions?
I have a more generic question. Excuse me if I'm just out of the loop, but how much you mentioned reconciliation? How much is topology service in general in the critical path of everything?
It's in the critical path of every routing request, unfortunately. So if something is not in topology service, and we want to route to that, like for example, if a user is not there, we might not be able to route any specific user information, but we might be able to route to the project of the user, because we will have different routing logic. We'll mostly route by path going forward. So if a path is there, it will be routable, but if it's not there, it's not routable, unfortunately. So it is in the critical path.
So for example, we wouldn't be able to create a new user, but for users created last week,
yes,
we may be able to still route to.
Yes, we have caching layer on HTTP router, so HTTP router will cache responses from topology service. So for example, if it will classify GitLab or GitLab, it will store it in cache. So even if topology service goes down, we can still route requests. But yes, if topology service is down, users can't be created and whatnot. And when we looked at the data, it's only like 50 requests per second that we need to handle, like user creation and updates and things like all the claims that we looked at are around 50 requests per second. So even if topology service goes down or like the claiming is not working, at worst we're gonna start responding to those 50 requests per second. So
no, it's not 50 requests per second, right? And those are two different things. One is creating and the other one's reading. And the reading part is actually far more than that, right?
Yes. Yeah. For model updates, it is 50 requests per second. For reads, yes, it's much
But that doesn't always need to go to topology service, if I got it right.
Yes, it will be cached in HTTP router, and this is why we want to route by organization, right? The lower the cardinality, the more cache hit ratio we have, right? So organization is going to be our least cardinality cache key, if we want to call it that way. So the more we route by organization, the better. But if we route by user ID or project ID, the more stuff we have to cache, and the higher the misses are going to be. And that's why we've been working on introducing the /o path so we can route by organization.
So for now, just to add a bit more color. For now, it doesn't matter too much if topology service goes down. We just fall back to routing towards the legacy cell, right? Because that's where all the customer data is, or 99% of customer data is. But there is a feature where all the customers like even spread out across all cells. So you cannot know, say, the ACME organization is in cell 1 or 2 or 3 or 4 or 5. So if topology service goes down, then you legitimately cannot route. You can look in the cache, but that cache may be stale or whatever, but you can sort of guess. And that cache has a TTL and a hard disk as well. So that is the reason why topology service is designed as a HA. It uses cloud spanner as a highly available data store as well, just because of that feature. So yeah, just to expand a bit.
Yeah, and we want it to be as slim as possible as well. So when we look at how much data we're going to store, it's around 50 gigabytes as well. So it's not a lot of data that we're going to be storing on topology service, purely because we want to stick to just the routing logic, and that's it. Because the more critical we make it, the worse it gets. There's that one. Any other questions? Cool. The other one is
I don't
gRPC
know.
logger.
Yeah.
Go ahead.
Before, because I'm interested in the way the cache will work, but I don't know how far you've gone with this. Like you mentioned, there's going to be TTLs. What kind of TTL are we going to be actively invalidating, or?
So the way it works, at least for HTTP router, is pretty nice because it uses the browser HTTP header, the HTTP cache headers. So inside of, let me open up topology service, and let's go to no, not this one, service customer. So here we will put in cache headers. Right now we're just doing it for 60 seconds, but then Cloudflare workers will look at the cache control and cache that response for 60 seconds using normal HTTP headers. And it's not a global cache, it will be a local cache. So even if there's like invalid, an old cache, it will be only done for that worker, and that worker is killed after a few requests anyway. So yeah, we will have one worker like by default. Cloudflare does one worker per pop. So yeah. Any other questions? Okay, so I'll move to the gRPC logger. This is again around topology service, part of the production readiness review. We wanted to add an access logger for our gRPC endpoints. And when we looked at it, LabKit has an HTTP access logger, which most libraries use, most projects use at GitLab, but it didn't have a gRPC one. So we've been building it with inside of LabKit, and I wanted to show a quick demo around it. So the code right now, we only have to just import the interceptor, right? So similar to middleware and HTTP, an interceptor, and saying unary service interceptor, and then some options that we want. And for example, here we can see we'll see the access log here. So saying permission denied, the duration, and the extra headers. I added an extra header here just in case we want to print something else, for example. And I didn't configure it, but it can log the context ID as well. And let's do a request of superb. No, I want to show this one. No, stream is in the way. But yeah, it will log all this information. I just wanted to show a successful request, but demo words are not in favor. Let me try and find one quickly here. Like for example, this one, we're sending the code when it started, the remote IPs and so on and so forth. So this gets feature parity with the HTTP access logger in LabKit as well. And this we're only doing it for Go. We're not doing it for the Ruby and Python log versions of Logit purely because time. So yeah.
That might be where we
Cool.
come in and try and get parity across the other three. Or the
Yeah, that's why I pinged you, Elliot. So I pinged you on the merge request.
So Gitly doesn't have this, or Gitly is doing their own thing.
So Gitly is using this package, which is gRPC, the gRPC interceptor, and using the access logger. So they have this is like a common package from gRPC ecosystem, and they have logging, and this is the access interceptor. We're using this one. We're just configuring it in an opinionated way. So putting the remote IP, only logging the finish and things like that. So Gitly uses the same package, just configures it differently.
Cool.
And this has been going back and forth because first we initially implemented our own, and then we found out, oh, there's the access logger from gRPC ecosystem. So we re-implemented that and configured it that way. So I'll link to the merge request for people who want to read more or share any opinions on that.
So right now, the only consumer will be topology service,
Yes.
but then we have a place to put our new things and start using LabKit for Gitly and yeah, anything else.
Yeah. Hopefully this
Nice.
this propagates to other projects. So yeah. Florian, I think you have pen number 3.
All right. So I recently had to do a bunch of changes for AI Gateway, and the changes were fairly trivial, just kind of reconfiguration for runway. And then the merge request pipeline ran for like 20 minutes, and then the merge train ran for 20 minutes, and then the kind of main branch pipeline runs for 40 minutes or something. So the end effect is that simple changes take a very long time. And I wanted to understand this better. I kind of looked at what we have, and what we do have in the product is something like this, which gives you kind of the information that the median time for these pipelines is like 1 hour and 3 minutes. And that's a very, very high level view of kind of how your pipelines perform, but doesn't give you a whole lot of information. In looking at kind of what's out there, I found a few solutions, but they were all kind of weird. Like they assumed that you would paste like a GitLab access token into a website and things like that. That didn't entirely feel like the right thing to do. And so I hacked together a little thing that I want to show you. It's a command line tool that you give like a project and a pipeline ID. If you run it, it takes a little while because it kind of needs to go into like trigger pipelines and gather a bit of data, and eventually kind of produces this Gantt chart. And that allows you to see that kind of the runtime is dominated by these kind of orange lines here, the lines that become orange eventually. So the performance tests, and they are dependent on the Docker build up here. So this is kind of the critical path. That is why the pipeline is taking long. I would have liked to actually compute like the critical path, but unfortunately we don't expose job dependencies via the API. There's an open feature request for it. So maybe if I have some time, I'll look into this. Like we have the data available. It can't be that hard to expose it, hopefully. Famous last words.
Or parse it out of the YAML.
Yeah.
Or parse it out of the YAML.
Oh, no, thanks. So yeah, I don't have this uploaded anywhere as of yet. But if people do find this interesting and helpful, I'm happy to do that.
I've been using the pipeline visualizer which does the same thing, but in the UI you just paste in the
Where do
pipeline.
I find that?
It's part of the engineering productivity team. So you open up it's the same thing, and you can log in for private. You can log in through OAuth, and you can paste in a pipeline, for example, here, and it does the same. Like to each his own. Like terminal is quite nice as well, but there's also this one that's
Okay.
publicly available.
Interesting.
And the web version also has the critical path implemented already, which is cool.
Oh, that's good. Yeah, thanks for providing a link. I'll take a look.
So to repeat this,
When I looked, I only found like community contributed things that were not productionized at all. And yeah, it didn't quite kind of feel right. But yeah, if we already provide something like that, maybe it would be worthwhile dropping a note into the pitch request that has been closed with a reference to kind of the CI/CD analytics that we have, but they're way too coarse to actually help you kind of optimize your pipelines.
okay, so that means it's company-wide.
I think that issue you're referring to has been closed because it's been moved to another. So
So that is, I can see if I can find it again, but the one I found quite explicitly said, yeah, I'm closing this because we have the CI/CD analytics now.
Oh, okay. Interesting. Okay. Sweet. Elliot, you're next.
Sweet. Okay, so to give you some context, I am in the developer experience team. I've been working closely with Bob, Stephanie, and a lot of the observability team, bugging them for the last couple of weeks, probably causing them no end of distress. But I've effectively
I haven't slept in weeks.
all my fault. Apologies. So one of the problems that's been highlighted to me when I've been talking to lots of other staff engineers across the company is trying to trace how logs effectively flow through our systems from service to service. There's a massive amount of inconsistency in terms of the field names that we use today. So like user ID, for example, could be interpreted as meta.userid or GL user ID, or there's a lot of subjective ways to name these things. So effectively what I'm trying to do is to define a pattern and practice for the company where we just become really opinionated about this and say, hey, these fields need to be determined and placed in LabKit, and you must be referencing them from LabKit, just so that we can gain some form of consistency across these services. And hopefully in doing this, our logs start to marry up nicely and it becomes a nicer experience to investigate these things. So I've got this initial patterns and practice doc. And it's super straightforward and simple. So it's just a case of basically importing from the fields package in LabKit the key name that you want to use, and behind the scenes we'll have the consistency across the different language runtime packages to make sure that these are all the same. Yeah, that's basically it. It's not overly complex. I wanted to bring this up to try and get alignment from everybody that we're happy for this to proceed, and we can start rolling this out generally, just getting teams to buy into this and to start adopting it. Yeah, I welcome any questions or concerns.
How are you going to do that last bit of interest? Get people to use it?
So possibly ask them very nicely and provide the carrot option. Say, hey, your logs are going to be easier to follow if you adopt this approach.
There's also a bunch of things that we're just going to do automatically, which will help bring the incentive, like the things that we currently call context, and we log in these meta fields that people have already seen. Those we can probably start just doing because those are already kind of like centralized. So we can take on that, and then that will look similar across services, and then people will see how nice it is. So if they want to use things like that in their own messages and whatever they log, they can adopt the approach.
Yep. And then eventually danger. When you go, Bob?
Go ahead.
No,
you go first.
Eventually, we're going to introduce the stick and then start hopefully enforcing these things more generally. So I think that's going to be through danger or DO reviewing your MRs. I'm
Stuff
still
like
too
that.
new to, yeah.
Like something that we will not do is drop logs. We're not going to like remove things that people log just because it's entirely like it doesn't entirely match the format that we know, and we might lose information. Yeah, that's something we don't want to do.
Cool. Let me know how I can be helpful in that kind of rollout and comms and other things.
Sweet, much appreciated. The plan was hopefully for us to land the initial MRs this week and then communicate it out to engineering at FYI. I'm open to help or suggestions about other places or how to do that. So if that's something you want to help with, then I'd be happy to take that offer.
Is the intention to just have it on for logs, or is it like, for example, even header something like that? Because feels very generic at the moment. Like
that's intentional.
I know, intentional. Okay.
Yeah.
And my other question is, are we going to look at some kind of code generation stuff? Because right now we have 3 versions of LabKit, right? If you update a field in one place, you have to open up 3 merge requests. So what I've seen other people do is code generation per language. Is that something that we're interested in, or is it more this is over engineering for the time being?
We did discuss that, and we figured going down the manual approach initially is sufficient. Like hopefully the lion's share of the work is going to be at the start. Like there's going to be an influx of fields getting added to these 3 things, and then hopefully it's like 1 field every so often, like every couple of months, say. Like I don't imagine this is going to be something that's continually evolving and growing. It should just be confined to fields that are pertinent across multiple domains.
Got it. Okay.
That's the hard bit, isn't it? Because initially someone just adds a few that you don't know, and then turns out we need to use it across multiple apps.
Yep.
Yeah.
But then there's like this kind of, because when we built the application context stuff in Rails at first, we kind of like made this a little bit harder because you need to define the field both in LabKit and in the Rails application to be able to log your thing. People didn't like that. So then we said, okay, let's just move it to Rails. So now we're going to have something like that you can log whatever you want, but if you want it to nicely propagate and so on, you will have to add it to LabKit. But we'll never block you from logging.
Can you
But
explain
we
what you
could
mean
block you
by
from merging. I think that's
no?
fine.
Depends what you're trying to do.
Yeah, it depends.
Like
that's what a maintainer can then decide. No, like yes, this doesn't really need to go across services or anything. Just log your thing.
Yeah.
Yeah, totally. I mean, eventually, when you've kind of rolled this out, it's very mature, then it's actually a reasonable gate rather than, you know, a just gate for gate's sake.
You have to be very clear what you're trying to do. Are you trying to log a field just putting into the Rails application, or are you trying to log a cross thing? Like, yeah, once you got that clear, then yes. I want to come back to what you mean by propagation, Bob, because I'm not clear what exactly
So
is the nice thing you're
the
talking about.
the thing that we're dreaming of is like you come in through Workhorse, you get a correlation ID that already kind of that already propagates, and Rails adds some more information, user and the root namespace, color, whatever, and then it calls Gitly. That goes into the headers for the RPC call and gets logged by Gitly. So we can have that. Like right now, we only do that for correlation ID, but then we do manual things for like a user ID. Sometimes it's a different field name. So the idea is that all these things that are valuable go through to all the services. So you can in your Gitly logs, you could see the root caller ID. You could see the user that triggered it, that kind of stuff for all of them.
Yeah, makes sense. Cool, thanks.
Cool. I think that was it.
Thank you very much. Bye-bye.
Cheers.